Okay, so I'm making you a video in my free, which is not really what I want to be doing, because I don't think you're going to manage this from just the notes. So if you were not at school today, you need to look at this video and then make sure you understand. So we have done a bunch of different types of sequences. We've done arithmetic, and so we know that the very first thing that we look for is we look for a constant difference. And if we have the first difference is 3, and then it's plus another 3 and plus another 3, then we know our sequence is 3n, and we know we're going to add our first term, which is 0, right? At least our 0 term, which is 1, right? So this is just trial and error. You have to look at the sequence, and you have to think, does it work for arithmetic, right? If it doesn't work for arithmetic, you can look and see if it works for geometric, right? So if we have, for example, 6 and 12 and 24 and 48, then that the first difference is clearly not going to be the same. And you should realize that we have not got an arithmetic sequence. And so then you're going to look for a ratio instead, and you're going to say r is equal to 12 over 6. Remember, this is every term over the preceding one. In order for it to be geometric, it must work for all of them. And then r is equal to 2, and then our sequence is going to be tn, and there's our first term, and then 2 to the power n minus 1. So those are the two sequence types that you're supposed to know for now. There is another one, which is a type of geometric sequence, and that's question 10. So because you weren't here today and you didn't see this, I'm going to explain this to you quickly now as well. So if you look at question 10, that's minus 2, 4, 22, 76, and it carries on, right? We only need the first 4 terms. If you go and you look for you check first of all to see if it's arithmetic. You'd look and see, is it linear? Is it arithmetic? That means the same thing, right? So you're going to say, okay, I'm going to go minus 2, that's plus 6, and then if I go 4 plus 6, that's clearly not 22, so it's not linear. Then you're going to look next and see, is it geometric? If I go 4 divided by minus 2, then that's going to be minus 2. So I'm timesing by minus 2. So minus 2 times 2 is 4. 4 times minus 2 is minus 8. So it's clearly not an ordinary geometric. However, this one is still geometric. When you go and you look at the first difference there, I'm going to say that is going to be 6. And then from 4 to 22 is going to be 18. And from 22 to 76 is going to be 54. Do you see over here that that was a geometric sequence? The first difference. When we were doing the geometric sequence, the first difference was also a geometric sequence. And this is the first difference, and it's also a geometric sequence. That's also a geometric sequence. So there are two types of geometric sequences. There's the common type that you're used to seeing where you can see the multiplication factor like this, right? Where you can glance at the sequence, you can see the multiplication factor. And there's a second type of geometric sequence where when you look at the original sequence, you can't see it. But when you look at the first difference, you can see it there. And if you use the first difference, here, if you use the first difference, 12 over 6, do you see you still get r? And here, if you use the first difference and you go 18 over 6, and you say r is equal to 3, then that's correct. Now for this one, we use the formula Tn is equal to ARN minus 1. You can't just plug the second type into that formula because it is clearly different. So this one, you just have to think a little bit more. There is no 100% set formula, except that we do know it's 3 to the power n. And if you know it's 3 to the power n, then you can work out the rest of the formula because that's the hard bit. So if I say my first term is 1, my second term is 2, my second term is 3, and my third term is 3, there's my fourth term. If I go 3 to the power 1, because after all n is 1, okay, then I've got 3. How do I get from 3 to minus 2? I subtract 5. If you go 3 to the power 2, that's 9. 9 minus 5 is 4. If I go 3 to the power 3, that's 27. 27 minus 5 is 22. So it's a different type of geometric sequence. Okay, on to quadratic sequences. So quadratic sequences, they must be different from both of those, from all of those. So here is a quadratic sequence. So in addition to this video, the notes that I gave in class will also be up. So when you make notes, you probably should look at that. It will be better for making the notes from. Okay. So this is your term. If you go and you work out your difference, that one is going to be 13, that one is going to be 25, and that one is going to be 37. So it's clearly not arithmetic. You're not going plus 3, plus 3, plus 3, plus 13, plus 13. It's not arithmetic. So we know it's not an arithmetic sequence. In addition, if we look at this first difference, it's not geometric. If we look at the original sequence, it's not geometric. You're not multiplying by something. So it's not a geometric sequence. Then, if you notice this is a pattern. What you're doing is you're adding 12 every time. So the second difference is the same. That's the defining feature of a quadratic sequence. You're going to look for the second difference, and if the second difference is the same, it's a quadratic sequence. So we know for sure that this is quadratic. The formula for a quadratic sequence is an squared plus bn plus c. That should sort of make sense because quadratic means something squared, so there's your square. A is not your first term, unfortunately. So that's a difference between this and the other sequences. But you are going to find A first. So the first thing you're going to do is you're going to find A. A is always, without any exceptions, the second difference divided by 2. So the second difference for this one is 12. 12 divided by 2 is 6, and A is equal to 6. So we know that our sequence is 6n squared plus bn plus c. Now, very often you don't need to work any further. They are very often very simple. Your ones tend to be very simple. So it will be 6n squared plus 2, or it will be 6n squared minus 3, or it will be something like that. So you could go and say n is equal to negative 3, or at least n is equal to 1, sorry. N is equal to 1, so 1 squared is 1, times by 6 is 6. And then you could say, well, to get from 6 to negative 3, I'm going to minus 9. And you could try that and see if it works for the whole sequence. It's not going to for this one, because this is an especially hard one, because I'm trying to show you a method that works always for every sequence. So you could, after you've got the 6n squared, you could just look at the original sequence and try and figure out the rest by yourself, or you can use the whole method. The whole method means the second thing we find is C. You've got to go in this order, else it doesn't work. C is the zero term. So in other words, here, there's a term, that's C. The reason C is the zero term is if you've got Tn is equal to an squared plus bn plus c. If I put a 0 where the n is, then I've got a times 0 squared plus b times 0 plus c. So you can see that term 0 is c. Now that is the hardest thing to do here, is to go back and find term 0. You have to be very careful. You need to start with the second difference, and you know that the second difference is 12. And then you need to look at the pattern and say, look, I went 37 minus 12, I got 25. 25 minus 12, I got 13. 13 minus 12 is 1. Sometimes you're dealing with negative signs. If you don't do this carefully, you're going to get it wrong. Then you need to look and see, what did I do to get the first difference? 72 minus 37 is 35. 35 minus 25 is 10. 10 minus 13 is negative 3. Negative 3 minus 1 is negative 4. That is your zero term. So now we know what C is. C is negative 4. So your sequence looks like this. You know what A is. A was 6. We don't know what B is yet. And we know what C is, which was negative 4, right? Yeah. Must have it on the next page. There it is, minus 4. Okay, so we've got that information there. For your sorts of questions, you get that will often be the answer. There will be no B term, and it will be 6n squared minus 4, right? However, this one is not like that. This one is hard. You still have to find B. Our last step is to find B. If you have term 1, well, let's first of all just show you the formula again. If you have term n, it's an squared plus bn plus c. If you have term 1, it's going to be a times 1 squared plus b times 1 plus c. So A times 1 is A, B times 1 is B, and there's C. So term 1 is A plus B plus C. You know what term 1 is. Term 1 is, there it is minus 3, right? So we know that term 1 is minus 3. We know that A is 6, we worked it out already. We're solving for B, and we know that C is minus 4, we worked it out already. So I've got minus 3, 6 minus 4 is 2 plus B, and B is equal to negative 5. So the sequence for this one is Tn is 6n squared minus 5n minus 4. And if you go back here and you take this value and you do that to it, so you take the 4 and you say 4 squared times by 6 minus 5 times 4 minus 4, I guarantee you'll get 72. So for quadratic sequences, you don't need to do much more than that. They're relatively easy. The homework for today is to start on page 10 and do the examples from page 10, 11, 12, and I think you can stop on page 13. There's an alternative method, so you're going from page 10 to page 13. There's an alternative method on page 13. You can look at that and see what you think of it, and we'll discuss it in class tomorrow if you're very keen.